Next, we are going to discuss infinite geometric series and factorials. So the formula for an infinite series formula for a geometric infinite series, is the sum, right? Because series is sum. Infinite, infinity sign, equals a sub 1 over 1 minus r. Okay? Now the only thing we have to be careful of is that the r value is in between 1 and -1. Okay? That's the only thing we have to be careful about. All right? So let's get started here. So it says find the sum of each infinite geometric series if it exists. If it does not exist, then state so. All right, so we've got a sub 1 equals 20, r equals 1/4. So we're literally just going to plug that in to this formula here. And this is going to exist because the r value is in between 1 and -1. So we can go ahead and find that sum. So we're going to do 20 divided by 1 minus 1/4. So in your calculator, we have 20 divided by parentheses 1 minus, I'm going to put the fraction in parentheses as well. Okay. You can give me the fraction answer. If you guys want, you can use the fraction function as well in the calculator. It just depends on what calculator you guys have, okay? But you get the same answers. All right, so 80 over 3, which we saw was, it's about 26.6 repeating. Remember, we used the little bar to show the repetition. Okay? All right, number 2. We have an r value of -1.5. Notice that is not in -1.5 is not between -1 and 1. So this does not exist. The r value is too small. Okay, it's like over here, it's too low. Okay? All right, number 3. Okay, on this one, we need to find the r value to see if it exists. So to get from 1/2 to 3/8, remember, we can just find the common ratio by taking this term and dividing it by that term. So I'm going to go ahead and do that. So let's see here. 3/8 divided by 1/2. I get 0.5, or 0.75, I'm sorry, which is 3/4. So we're multiplying by 3/4. Let's see if that happens again here. 9 over 32 divided by 3/8. Yep, got that again. So r equals 3/4, which that is 3/4 is between -1 and 1. So I'm golden there. So now I just need the a sub 1 value, which is 1/2. So the infinite geometric series would be 1/2 divided by 1 minus 3/4. So I have lots of fractions here. 1/2 divided by 1 minus 3/4. I got 2. Okay, now if you don't have all those fancy buttons, I would do parentheses 1/2 divided by 1 minus, divided by the parentheses of 1 minus the parentheses of 3/4. You got to put in those extra parentheses there. So make sure you're checking in with your teacher of how to type that in if you're having trouble, okay? All right, here, this geometric sequence, it looks like we're multiplying by -2 each time. Yep, so r equals -2. Notice -2 does not fall in between -1 and 1, so this does not exist. Because r is too small again. Okay? All right, number 5. Okay, so notice that we have the sigma notation. This is the summation notation, right? But typically we have the first term, and this will tell us what term we're going to end on. You cannot type infinities into your calculator. So when you end up with something like this, you do have to use the infinite series formula, which, just as a reminder, was that right there. Okay, where r is in between -1 and 1, which r is in between -1 and 1, as we can see right there. Okay, because remember, this is the geometric setup for the geometric sequence formula. Okay, so that's r 3/5, and we're good to go. So I'm going to just identify that a sub 1 is 40 and r is 3/5, and I'm going to plug that into this formula here. A sub 1 is 40, r minus 3/4, and, oh wait, I'm sorry, that says 3/5. It's like, where did I get 3/4 from? There we go. All right, let's type that in now. So use what you need to do for your calculator, whichever one you have. I got 100. If you're not getting these answers and you're having calculator issues, ask your teacher, okay? All right, over here, again, we have the summation notation. Notice that the r value here is 4/3, okay? 4/3 is outside of the interval from -1 to 1 for the r value, so this will not exist. Because the r is too big this time. 4/3 is bigger than 1. See? Okay. All right, number 7. So Kim's little sister likes to ride on the swing at the playground. When the swing is pulled back, it travels 9 feet before heading the other way. Each swing afterward was only 70% of the previous one. Find the total distance that the swing traveled. So when the swing is pulled back, it travels 9 feet before heading the other way. So that's the first distance that the swing travels, right? Yes. Okay. Then we know that each swing afterward is only 70% of the previous one. So that means that we are multiplying each number in our sequence by 0.7. 70% is 0.7 when you move your decimal 2 places to the left. And if we can imagine a swing going back and forth, it just goes on forever and ever and ever until it completely stops on its own. So that's why this is an infinite geometric series, okay? Now, the r value is in between -1 and 1, so this will work, okay? Remember, if the r value is not in between -1 and 1, it will not work. So I'm just going to go ahead and plug this in, or do my setup. So here's my formula. So a sub 1 is 9 over 1 minus 0.7, because that's my r value. So I have 9 over 1 minus 0.7. So 30 feet, because we were at 9 feet. So we got to include units when we are doing application problems. So the total distance that the swing travels is 30 feet. Okay? On to the back. Factorials. So factorials, it's a symbol, okay? It's an exclamation mark, okay? If you see that, you're doing a factorial. So the factorial function symbol is this exclamation mark, and it says to multiply all the whole numbers from the chosen number down to 1, all right? So these kind of like pop up on like some standardized tests and stuff sometimes, so that's why we wanted to show you this. So it says to multiply all the whole numbers from the chosen number. So in this case, the chosen number is 3. So we're going to multiply all the whole numbers that start at 3 and count down to 1. So 3, 2, 1. You literally are multiplying those into your calculator, okay? Or if you can do it in your head, do that too. 6. Okay, so 7, that's our chosen number, so we're doing 7 times 6 times 5 times 4 times 3 times 2 times 1. It's just a countdown. Okay? 7, 6, 5, 4, 3, 2, 1. Now this one was easy for me to do in my head, but this one I'm not doing that in my head, so I'm going to type that in. Okay, and I got 5,040. All right, now let me show you a trick, okay? In your calculator. Your calculator has some fancy buttons in there. And this should not matter what kind of calculator you have. They all should have them. But if you guys hit math and go over to probability, so you use factorials in probability and like stats sometimes, okay? So go over to probability and scroll down to 4. That's the exclamation point, okay? So when it says to evaluate each of these, we're just going to type this in the calculator. So I'm going to do 6. Math, probability, option number 4. And that's what this is saying over here, okay? So I have 6 exclamation point, which you do not, that's not how you say it. You say 6 factorial, okay? But I'm just showing you like, yeah, we have the exclamation point. So this is 720. Okay? All right, over here, number 8, we have 13 factorial divided by, ooh, that's a big number, 9 factorial. 17,160. All right, and the last problem here, we have 12 factorial divided by, I'm going to type these in together, so I'm going to put parentheses around this denominator, 2 factorial times 10 factorial, 66. Now again, if you are not getting these numbers, talk to your teacher. You're probably just typing this into your calculator incorrectly, okay? All right, that's it.